Hello, all you transformer testing aficionados. The first test we will show today is a ratio test. It's one of the basic tests you do on a transformer, which checks if the number of windings on the primary side and the number of the windings of the secondary side is what you need it to be. How you do this test? Very simple. You generate on the primary side and you measure on the secondary side. Let me first present to you our little blue transformer, the little blue. It has the power of 100 kVA, and on the primary side it is 18.5 kilovolts, and on the secondary side we should measure 400 volts. So the ratio is about 80. That's what we will see later when doing the test. Now, for this particular test, for the first test, we will test phase A. Effectively, on the primary side we will connect 2 kilovolt output, but we will not generate 2 kilovolt, we will generate 200 volts. So I connected phases A and B, and on the secondary side, I'm measuring between phase A and neutral, because the vector group of this transformer is DYN11, which means that I have a delta on the primary side, that's why I'm doing between phases, and on the secondary side, I have YN, that's why I'm measuring between phase A and the neutral. So connected like this, let me go and start the test on the STS. So we are here now and we will do the ratio test. What we do is we choose Power Transformer, and in the Power Transformer, we'll first check the header values. Now we see that we have here some data, which is at this point less important. What is important are the nominal parameters. In this case, we have a 100 kVA small transformer, 18.5 kilovolt to 400 volt on the secondary side. So primary 18.5, secondary 400, and the vector group is DYN11. We press the button test and we go into the ratio test. We open the application. Once the application is open, what we do is we check if these data are correct. The data are correct, and the only thing you need to do is to verify if the voltage is okay for you. As we said before, it's important that you don't generate more than the transformer can effectively sustain. Another important thing is that if you're not sure how to connect, by pressing the button, here the question mark button, you see how the connections need to be done. So in the first test, we will generate on the primary side high voltage on phase A and the neutral on phase B, and on the secondary side we will measure between, this is on the secondary side, and we will measure between two phases, between neutral and phase A. So let me do the first test. I'm here and I will press start. What we can see right now is that nominal ratio is 80.107. We measured 80.243 and we press keep values. We can then go down, scroll, press scroll columns and see the error of 0.17%, which is a good number because, as we said, 0.5 is the maximum error. Now I'm going to change the connections and do phase B. So having done the first test on phase A and having obtained good results, we need to change the connections to phase B. So let's see how we do that. Very simple. So now I will be generating between phases B and C, and I will be measuring on the secondary side between phase B and neutral. Having connected like this, let us do the second test. So we changed the connections and now we will test phase B. I'm connected now, so between phases A, B and C on the primary side and B and neutral on the secondary side. Again, I have to mark the phase I'm testing and I press the button. STS will generate 200 volts, as we can see here, and we see the ratio almost the same like phase A. We are happy, we press the button, keep values, and we can see good result because this number and this number coincides. And another thing, we can again scroll columns and see the same error, phase A and phase B, and the error is 0.17. Now we need to finish and do phase 3. Right, we've done phase 2. Now let's do phase 3. So, like we've done before, let's change the connections. Now the generation will be between phase C and phase A, and the measurement will be C and neutral. Like this. Let me go and press start. So I press the button, the device will generate 200 volts on the secondary side of phase C, and we will measure between phases A and C on the primary side. So right now we see basically right away that the number 80 coincides with the number 80 here. We press keep values, and let's look at the errors. Once again, we come here, I press scroll columns, and we see all the fingers, all the hands showing up, and it's green, so the error is very small. We can also see that the phase shift is what we expect, and you can also see the basic numbers like how much we generated on the secondary side, how much we measured on the primary side, and we can also see the current which was running inside, but we'll talk about that later. So this is how we did the ratio test. Let me just point out one thing. For the purpose of this test, of this ratio test, we've done test phase by phase. We have the option to do it 3 phases at the same time. Then we would use something which is called STS, and the connection would look something like this. This would allow you to do multiple tests without any change of connections. But if I had used STS, right now you wouldn't be able to see how the test is done generically. So, having done the ratio test, it's a good idea to, of course, do the vector group test. As mentioned before, the little blue has a vector group of D, Y, and 11, which means on the primary side we have a delta connection of 3 windings, and on the secondary side we have the connection of star connection. So for the first test, let me explain how we will do the connections. We will generate on the primary side between phases A and B, and phases B and C are short-circuited. So phase B and C on the primary side is short-circuited. And as I do a test, I will not touch this. The primary side stays the same. The only thing I will change is these, the secondary side. So for the first test of vector group, I will be measuring between phases A and B. And for the second test, I'll just change this from B to C, and I will be measuring phases between phases A and C. And that will give me DYN 11 vector group, hopefully, if the transformer is good. So let me start now with the test. Now we choose the vector group test, press the knob, the test opens, the application for the test opens. Turn ratio is, as we measured, 80.107, right? As we can see, we can see that on the low voltage side we have the neutral, so I say yes, and this is added here. And now I move on to execute the test with the voltage on the primary side 200 volts. I start. The test stops automatically, and now I want to do the second test. The only thing that will change, look here, is I won't be measuring between A and B, but between A and C. So let me go and change the connections. So now I'm changing this, only this, from AB to AC. And now I do the second test. Let's do measurement between phases A and C. And automatically we got the result DYN11, which is what we expected. So a successful test.